Hi guys, in this specific display we are going to look at the concept of ionization of atoms or ion formation in atoms. Now we had said that atoms can exist as a neutral particles or charged particles, and when we talk about the concept of ion formation, then therefore it's going to refer to as charged particles. This can either be either negatively charged or positively charged. And we are going to see that for these atoms, they are going to display similar properties to other particles that we are going to see being given as charged particles, especially that we have encountered in various studies on other aspects like electricity, electrostatics, etc. So if we try to look at this specific illustration that I've given, this is showing the number of protons, neutrons, and electrons in an atom. And in this case, if we try to look at some of the characteristics of an atom, as we had said, the subatomic particles, which are protons, are positively charged, and electrons are negatively charged. So if you're going to have an equal number of these specific protons and neutrons, and therefore these charges are going to cancel out for positive and negative, and we're going to have what we refer to as a neutral atom. Therefore, for the same number of protons and electrons in an atom, this is going to give us a characteristic atom that is neutral. Now, in our second case, if we try to look at the subatomic particles or the content of this specific atom, we have 6 protons, 6 neutrons, and 7 electrons. Now, as compared to the first one, then therefore we're going to have one extra electron as compared to the proton, and therefore this is going to create a net effect of a negative charge, since we have said that electrons are negatively charged. So in this particular case, then therefore it's going to give this particular atom a characteristic of a negative charge. And therefore, this is the difference between a neutral and a charged atom for the negatively charged atom. And if we try to look at the last one, of course, we're going to have 6 protons, 5 neutrons, 6 neutrons, and 5 electrons. Now, compared to these first 2 subatomic particles, we have a deficiency of an electron, whereby we're going to have an extra proton that is not going to have a partner, of course, to pair with, insofar as this, of course, interaction of our charge is concerned. So therefore, we're going to have an extra positive charge. And this is going to have a net effect of having a positively charged particle in this specific case. So therefore, this is how we can be able to illustrate the concept of charge. So some of the areas which, some of the reactions which are going to initiate the process of gaining of electrons or release of electrons from an atom are going to have a net effect of causing a charge of either positive for excess electrons or negative for deficiency of electrons and in excess of protons, respectively. So in this case, of course, we can as well therefore say that a neutral atom has equal number of protons in its nucleus and electrons in its orbit about the nucleus. We had defined earlier that neutrons and protons are found at the center of this specific figure for an atom, and electrons are the red ones which are being shown revolving around therefore the energy levels. So there's going to be a difference. We had referred to these protons and neutrons as nucleons, and therefore these electrons are not going to be part of the nucleons. So the forces of attraction are going to be experienced from this nucleus into the orbit, whereby these electrons are just revolving. So in this particular case, therefore, this is how we can be able to define the concept of ion formation, where atoms, neutral atoms, are either going to lose electrons or gain new ones in order to form charged particles. So catch us in our other videos as we're going to look at various other concepts which are going to pertain to the concept of ion formation in atoms. So that is it for now, guys. Bye, God bless.